Okay, so let's launch into our next session. Our first speakers this morning are Rich Hauer and Ryan Gilpin, who will share with us ISA's best management practices for construction near trees. Richard Howard is the Director of Urban Forestry at CNUC and a Professor of Urban Forestry at the University of Wisconsin-Stevens Point, teaching courses in urban forestry, nursery management, woody plants, dendrology, and intro to forestry. Rich received his BS from the University of Wisconsin-Stevens Point, his master's from the University of Illinois, and PhD from the University of Minnesota. Rich has conducted research in tree biology, urban forest management, emerald ash borer management, trees in construction, tree risk management, and ice storms. Rich was honored as the 2018 L.C. Chadwick Award for Arboricultural Research. He's published over 180 publications and presented over 450 talks throughout the world. Dr. Hauer is also an associate editor of the journal Urban Forestry and Urban Green Spaces. Ryan Gilpin is the principal consultant at Nidus Consulting in Portland, Oregon. Ryan specializes in tree preservation projects, completing hundreds of projects and training several consulting arborists along the way. Before becoming an arborist, Ryan's background was in conservation and ecology, with degrees in environmental biology and international nature conservation. Ryan is co-author of two best management practices, Tree Care for Birds Wildlife BMPs with the Western chapter, and ISA's Managing Trees During Construction BMPs. Let's welcome Rich and Ryan.
Greetings. Okay.
Yeah.
Hey, how are you? Dangerous. How are you doing now? Is your hearing okay? All right. So it's my pleasure to get to speak with my great friend Ryan here today, and I've got to know him over the last year or so working on this project. First of all, can you believe you get people together and you don't always agree? And so interesting enough, on definitions, you'll hear a little bit today about like tree protection zones, and maybe use the term critical root zone. You'll hear some reasons why we've got some differences in terminology, but we're not going to get into that right now. We're going to get into some of the reasons perhaps and the science perhaps behind this. Now, I don't have to educate you in the room that there's a different variety of ways we can kill trees, right? The thing is, to get to the stage of actually being on the planning component where we can avoid these, that's the part of our message here today. The sad part, this is my university. You'd think a school that's had 50 classes in urban forestry, taught almost 1,500 students, could actually know how to do trees in construction. No, we actually have no part of the planning process. Actually, at the state level in Wisconsin, when they do trees and constructions, they just do construction. Trees are not, unfortunately, are not part of the whole process. We've tried. Now, you can also kill trees in 1 year, right? Interesting enough, this is a case study of a town my mom grew up in central Minnesota, and they had trees and construction type deal, heritage trees. You had to retain them, okay? But they had nothing about trees and where you put the soil. And interesting enough, I wish I still had the pictures that had the D9 caterpillar up there pushing soil, but within 1 year, most of these trees died. Now, for many trees, it's usually a decade or so, okay, where you can see the kind of the spiral downward if there's enough damage, whether it's curbs or roads or piles of soil, a whole suite of things. And Dr. Susan Day and Nina Basic, Dr. Basic, they came up with a really good publication about 20 years ago that compiled a lot of different, from the scientific and other practitioner findings on how much time it takes to actually kill a tree. We can even take maybe a century or more. So for example, this giant sequoia, rather than doing the construction around the tree, actually construction right through the tree, putting a road. Now, if you know much about the Cuprosaceae family, there are a lot of species that have great rot resistance, like bald cypress, cedars, including giant sequoia. So it doesn't surprise me that just from the wood degradation process, the whole compartmentalization and decay process, or damage or dysfunction, if we use those terms these days, that it took over a century for this tree to fail. And if you look at some of the attributes of the wood fibers here, those of you that actually do work in biomechanics, you could probably say, yeah, that was degradation. That was just tissue just waiting to fall down. So the whole point here is obviously you'll be hearing about the planning process and how to get involved from day one on avoiding the biological aspects here. Now, sometimes on the planning stage, things just happen. And here it's like, well, someone didn't account for the trees in the construction zone, but you do have a buddy with a chipper, or a stumper for that matter, and now we can actually put the transformer in place there. Now, often science or things happen because of an event. Now, some of you in this room, I know who Bob Scarra was. You know, Bob was a city forester in Milwaukee up into the early 1990s. And early career days as a student, I got to know Bob, and he was just a wonderful individual. But Bob gets a call in the morning and says, hey, Bob, 400 of your trees fell down, and some of our constituents are not happy. They can't get to work today. Okay, what are we going to do about this? And back at these time period, it was not uncommon for trees in street settings near curbs and sidewalks. How do you avoid the damage to a curb or a sidewalk? You sever the roots. Okay, so just classic, like how close can you get to a tree before its biomechanics are affected enough? But this whole process started in line some work I'll just briefly talk about, trees and construction, that I got involved with when I was an undergraduate student. And if you want, this publication's behind a paywall, but for your attendance here today, just drop me an email. You can actually Google my last name, Hauer, and you'll find me right away on Google. Just send me an email from that link, and I'll actually send you a copy of this paper. It's pretty dense. It's like a lot of scientific papers. If you have insomnia, they'll cure it. But on this whole set of research, back in 1979, the city of Milwaukee had a tree inventory. So we actually had baseline data to say there was no difference between trees that were later in construction areas versus those that were not. And what did we find the first time we looked at trees back in 1989? That's when I was a young kid. Okay, I still feel young. But anyways, 1989, we found that you can affect the condition of a tree if you do construction near them. And I remember telling my dad that, and he'd scratch his head and said, son, I could have told you for a lot less money that if you damage trees, you may affect their health. Okay? But anyways, what we found was we had about a 5 to 6% impact on construction on the condition of a tree, the health. Does that mean a lot? Actually, yeah, I'll show you some data that you can actually kill trees, which I showed you earlier. So anyways, but as this program of trees and construction evolved, getting some science in the process here along with just the practitioner output here, that over time, as you're doing more about how you understand the biology and how to actually work with contractors and how to actually set up contracts, for example, that over time, and most recently when we re-looked at this tree population, there's no difference between trees in construction zones and those outside for tree health. Okay? Now you can't compare one year to the next year because all the trees that we have at any time period, like 2018, like in 2018, some of those trees were affected by like leaf anthracnose. Okay? But nonetheless, there's no difference statistically between tree populations. The same thing with mortality. Okay, we used to actually be able to kill trees at a higher rate back before the program was evolved. However, today, and write this down, as a consultant, you get hired to come into town and they ask you how best to maintain the health of trees and increase survivability. Tell them, do construction near them. Because that's what the daddy says, right? Statistically, we had a significant, and I scratched my head going, this does not seem logical at all. How can you do construction near trees and increase their survivability? What do you think? I'm hearing some chatter back there, and I think the right answer is coming out one way or another. Actually, growing space. So to actually minimize damage to trees, you don't do construction where you have root zones. And so in the street setting, to actually put a street in and minimize damage to the root system, they make streets smaller. So trees are getting more growing space in the same process. And when you control for that factor alone, you can actually detect why trees are surviving at a higher rate. I think that's pretty cool. So yeah, don't do construction near trees first of all, but if you have to, stay far enough away. Ryan will talk about the planning stages behind all this. But nonetheless, that was a cool finding. More growing space, and this data also shows it. This is just an odds ratio of tree survivability. And so the bigger the growing area, the bigger the growing space, the greater likelihood of a tree surviving if it's in a construction area. And two things. One, I just told you, where you actually have greater growing space. The other, the further away you are from the tree, the less impact you're having. Okay, so comparing a 10-foot to actually a 2-foot terrace, you have about a 2 to 3 times greater odds of survivability if construction's in that area. So growing space matters, correct? All right, we have data to prove that up. Now, this is how they used to do trees in construction. Now, I think excavators are phenomenal people, because if you tell them to remove a curb, did they do that here? That's the specification. The answer is yes. All right, but if you say don't damage the root system, can they do it? You're darn right. So the specification was remove curb and do it without damaging or as minimal damage as possible. Also, City of Milwaukee, for example, has a fine that if you damage a tree and the assessor determines contractor damages trees, it's $100 diameter inch. So you can do the math. You got a 20-inch tree, that's $2,000. There goes the family's vacation trip, because that's all profit, right, for a contractor? All right. The other thing is equipment. So just the needs of equipment in doing construction. This is just one of these great machines that put in concrete for curbs. And actually, by default, by design, from the factory, they need about 12 inches or so of space for that chute. And the old days, you'd have this line that they'd run across. And Jim Kringer, who is really the instrumental person behind the City of Milwaukee's Trees and Construction program, determined that, couldn't we modify that piece of equipment? Do you really need a foot? And the contractor's like, no. And he said, well, how much does it cost to modify? They said $50,000. So it wouldn't be fair after the contracts are all done that modify your equipment. Future contracts, though, you have to use what they call a zero clearance piece of equipment. In this case, they need about 1 3/4 to 2 inches of space. So yeah, shrink the streets by about 2 to 3 inches, more growing space, and you're not damaging the root system in the reinstallation of curbs. I think that's pretty cool. Now, write all this down, because if you're going to get CEUs today, you're going to have to put all this information down later. No, again, on that publication, this is really the City of Milwaukee's BMPs for construction street tree settings. All the things they put in place, and by deliberate, it's small text. I don't know, Jim, can you read this? Okay, there's optometrists to help with that matter, but nonetheless, I'm going to get into some science now that really gets into the fact of like how far away you should stay. Now, this is me as a young lad at University of Illinois. I got paid to actually withhold water from sugar maple seedlings to see how they respond to water physiology and stress. So this is just a little Scholander pressure bomb, if you've seen one of those before. And this is a gas exchange piece of equipment, a Lycar 6250 or something like that. And for about $20,000, you can do work like this. Now I think they're about $50K for one of these machines. And we'll also talk about like tree failure, of how close you get and the impacts on trees. So here's a really cool graph. I still scratch my head sometimes when I see this graph, because in some regards it's kind of not intuitive of what I was trained. It's like there's this linear dimension of diameter and root radius. And actually, according to this compilation of data that Susan Day put together, that it's more curvilinear. And to me, that actually makes sense from a biological perspective, because what happens when you double the diameter of something? The square area increases by a factor of 4. Okay, so as tree roots go further out, they have more space to actually grow. So biologically, it makes sense from that perspective, but I still scratch my head. It's like how curvilinear this is, but what do you see for data points? There's not many with big trees. It's easy to work with small trees, because if you want to get a master's or a PhD program, you don't want to be around for 20 years, right? All right. Now I'm going to get into some data. This is from Dr. Alessio Fanini from University of Florence. And what they found, looking at how far away from a tree, and they had 4.5 times the diameter of a tree distance away, and they looked at a couple species. One was one of their Tilia species, one of their limes, and also one of their chestnut species, okay? So a horse chestnut there. And if you're on one or two sides, the white bars are just the control. The darker bars are there on both sides. In this case, we're just looking at water physiology pre-dawn. If you don't know anything about pre-dawn water potential, you get up at dawn to measure what the water potential of a tree is. Make sense? The other part is you use that tool like the Scholander pressure bomb, and literally, as water's being pulled up the tree, it's like a rubber band. It's under tension. And the more pressure, it's negative. Okay, the more pressure, the columns of water are being stretched, and a tree doesn't want these stretched columns to break, cavitation, because that's going to impact the transpiration. So the tree itself certainly is going to stop transpiration by closing stomates. So in the process here of kind of self-preservation, you're reducing what? Energy coming in the tree because that ingredient of carbon dioxide is being impacted. In this case, we're just measuring water release, but the opposite with CO2 intake is occurring. But what do you see here? In the case of lime trees, after a couple of years, actually they weren't detecting stress, but with horse chestnuts they were. So certainly from a species perspective, that's also part of the planning. And Ryan might get into a slight bit about that. The BMPs plus the new publication, or I should say revision by Jim Clark and Nelda Mathaney. Actually, the trees in construction, that reference material is being updated and should be available this year. Now, this is just looking at water loss and then stomatal conductance. The same thing here. What I just kind of showed you. The above one is just stomatal conductance, and over time, the one down below is carbon uptake. And so they kind of go hand in hand. If stomates are closed, you reduce water loss, but in the same process, you're reducing carbon dioxide coming in. Okay, so over time, what do you detect here? There's species differences, and depending, in this case, 4.5 times away, it took time. So what would be a remediation? Certainly water management is the key critical aspect here. Now, do you have to get a shoreline or pressure bomb or one of those LICOR machines, spend $60,000 of equipment? No, first of all, it'd be silly, because you could visually look at a tree and look at what does the leaf look like? Is the leaf showing impacts of moisture stress or not? Okay, so just visual, a cue of an arborist on the site could certainly make those determinations easy. All right, so the same thing here, we could look at the force it takes to pull the tree over, okay? I suppose you've done this a little bit, Philip, right? Just trying to pull trees to failure. And if you look at this whole impact here, again, 4.5 times away from the tree based on diameter and on one or two sides compared to control. And here, even 3 years later, they're having the ability to actually detect it's easier to pull trees vertically over. And I'm going to actually end with later in about 5 or 7 minutes of actually if we look at some other work. And so here's just a case of horse chestnut and one of the hybrid linden trees from Europe, one of the lime trees. We're at 4.5 times away. Certainly they're having impact on structural stability. Okay? You'll see some other species that show a little bit different, some work that Dr. Tom Smiley did. All right, so the bottom line there is it's easier to pull trees to failure the closer you get to them. And I don't think that's like a rocket ship development, engineering mindset you have to really compile to figure this out here. But in this case, we've got some distance and some information to go by. Now here's another neat study, and this is actually done by Justin Morgenroth, Andrew Kozer, and grad student Andrew Benson. And they looked at the multiples of 3, like 3x, 6x, all the way up to 15x away from the tree to look at some physiology work and some pulling trees to failure work. And so here's just the simple that I showed you with the species from Italy, some species that are, in this case it's live oak from Florida, and compared to trees that had no construction relative to distance away, okay? At least you get some guidelines here of like 15x away that could still actually detect stress, in this case 3 months later. Okay, so obviously you're having some impact on the root system, but it's minor. And I would not actually be afraid from a physiology perspective of what I'm seeing for pre-dawn water potential. What later will happen probably during the day when you get temperatures that are higher at noon, for example, or at 3 o'clock in the afternoon, that there's going to be massive stress. I would be more concerned knowing the pre-dawn water potential of 3x though. That certainly water management would be critical, or more importantly, don't get that close to a tree, okay? And then if you look at like the amount of cross-sectional area. So one of the cool things about like giving presentations or kind of looking at the science of things like this, it makes your mind think. And one thing I did not see in their paper, and I got to call Andrew and think about this relating. Diameter relative to cross-sectional area. Because if you know like trees in biomechanics, if you've got the parent stem, the stems that branch off of that surface area is equal to the parent stem, okay? And so I imagine the same thing goes on with the root system, but I don't know of anybody that's ever done that. If there is, and you know about such a paper, let me know, because that'd be pretty neat. Because then could you somehow make me relate diameter to cross-sectional area? So if damage is occurring to a root system, and you can measure that, you can then maybe make some determinations of, is this something that's critical to worry about or not? That's just a thought. I have nothing more I can present on that beyond my just thought sitting in a hotel room. It's like, what about that? All right, and this is just another study. Bottom line is 2 different study sites. They're finding the same impact of like measuring cross-sectional area of the trees here. And it probably doesn't surprise you. The further away you get, the less cross-sectional area. And if you're wondering what that is, it's nothing more than here's this eccentric root system that they're just measuring the area of that root. Now, same story, different species. In this case, they had well into about 1.5 years of time. We're detecting stress. And the neat thing here is, what do you find out? 12X, for example, with live oak in this regard, looking at just pre-dawn water potential, that over time, beyond 90 days, you start getting that the trees are recovering from that by maybe root regrowth and things like that, that statistically no difference compared to the controls, okay? Now the last thing I'll talk about and then turn it over to Ryan is if you look at structural stability. In this case, it's, you can look at the BMPs and they suggest 5X is one of these critical factors that when you start getting closer to a tree based on 5X, maybe you should start being concerned about the ability to pull that tree to failure, or maybe actually get some expertise in there looking at the tree of what you might have to do from a management perspective of just the potential for stability. So the first one I'll show is, and the neat thing here is there's 3 different species, and if you think about the root biology, there's some differences. So willow oak, root systems tend to be more fibrous and not as deep as perhaps a pinus member. And so here, if you look at 1X or 2X or 3X or 4X with this data set, compared to being right at the trunk, statistically you could get within about 3X and have no difference in the force needed to pull trees to failure. Now when I say get within 3X of willow oak, no, I would say stay as far away as possible, and there's a lot more to it than just that. It's like where do utilities going to be placed, where are footprints of buildings, et cetera. In the case here, there's some data on this species. But then if you look at red maple, in this case you could get a little bit closer, but if you've ever looked at a red maple root system, they're more oblique. Okay? So here, based on root system biology and depth, certainly that has some impact on the physiology. And then if you look at this perspective here, this is actually with Virginia pine. In this case, actually, they're able to get within 1X, and statistically being no different compared to further away from the tree. Now, I'd say get within 1X of Virginia pine. No, I would just say from an illustration perspective, we have some data saying on root system biology, that's another thing to consider. Well, appreciate your time. I'm going to turn it over to Ryan, and we'll go from there.
Remember to keep our distance. All right, we're going to change over to a different PowerPoint here, and I could listen to Rich talk all day about the science of this. I really enjoy it. I really think it's interesting. But we're talking about the best management practices here. We should probably talk about a little bit of practice and bring in some of my experience, some of what you can expect to see in the new edition of the best management practices. The 3rd edition should be coming out in the next month or 2. And so I want to get you all a little bit of an idea of some of those changes that might be, and we'll talk about how I might approach some of those things. And so when I'm working with my clients, when I'm training new consultants in how to offer these services, we think about, we talk about, we ask each other, our clients ask us all sorts of questions. And we could spend a lot of time on any one of these questions. But I think that what I see arborists who don't have experience in trees and construction struggle with the most is the tree likely to survive construction? So that's what I'm going to focus on today, although we could spend time on any of these in the Q&A and other things like that. And that we have in the 3rd edition 6 phases of construction, right? It goes from planning to design to pre-construction, construction, landscaping, post-construction. And that again, we could talk about, is the tree likely to survive construction? We may get asked this during the construction phase with no idea about what happened before and try to answer that question. But most of the time, I try to answer this question in the design phase. I get asked to answer this question in the design phase. And so we've added this to the 3rd edition of the best management practices, right? So in the 2nd edition, it does not say anything about plan review. It does not say anything about tree impact assessment. And so that was something that we wanted to make sure that we brought into the new edition, that we want to say using the site plans and knowledge of the tree resource, the arborist evaluates which trees can be preserved and which should be removed or transplanted, right? And then it goes on to say the arborist should evaluate how trees near the limits of construction will respond to the site being graded, utilities installed, foundations excavated, buildings being constructed, right? And anything else that might happen out there on that site. And so I want to focus on this a little bit since this seems like a big, tangible change to the best management practices. So we're going to focus on this. Again, we could focus on just about anything. And the best management practices are so theoretical, right? Reading through them, it's hard to have much of a tangible idea of what we're talking about. So today, instead of going through the best management practices much, we're going to use the best management practices to talk about a tangible example. And so this is one of my projects that I've worked on in the last couple months here. And it's a little bit unusual for me. I do mostly redevelopment, but this is sort of a new development in a relatively natural area. And on these sorts of projects, you sort of identify the limit of grading, and everything in this blue area is going to be graded, so trees will all be removed from these areas. And the question is, what's going to happen around the perimeter, right? Around the edge. And I'll tell you that this site is a little bit unique in that it's sparsely vegetated, right? It's not a dense forest. In a dense forest, I would think about this quite differently. I'd be thinking a lot about edge effects and sort of those natural communities. This, I'm approaching it a little bit more from an arboriculture point of view of individual trees, if that makes sense. So I'm going to zoom in on this grading plan. I normally start with the grading plans. I normally review many, many sheets of plans when I go about doing this. We're just going to do one today. Trying to keep this relatively straightforward. I only have a few minutes here. So we zoomed in up here. So we have the property line on the top. We have our existing grade of those gray lines, vertical lines there. The black dash line is our edge of grading, our interface between those 2 points. And then you can see below that, the gray lines sort of break off to the left. This is going to be our new grade, what it's going to be when the project is complete, because they're going to install this parking lot and then plant these trees once construction is complete. Again, here's our blue line where we think all of this is going to be graded. And this isn't the same project, but just to give you an example of what that might look like, typically I'm imagining total destruction in this blue area here. All roots are removed, all whatever. Not always true for every project, but for this one I think it is true. We have a fence along this line, and then we have preserving as many trees as we can beyond that. Okay, back to the plan. We have some more information here. A survey crew went out and accurately located the trunk locations of many trees, but we're just going to focus on 4 trees today. I think that's about as much as we can handle today. The first thing that I advise new consultants to do, that I do when I'm doing this, is try to figure out which trees are definitely going to be removed and which are definitely going to be preserved sort of as fast as possible. Tree number 4, remove, not going to survive there. Tree number 1, pretty far away, it's probably going to be fine. So I've eliminated generally a large number of the trees, and I'm only focusing on a small subset of trees where I actually have to make difficult decisions. And so I know what you're all thinking. Is there any way we could bring in some really tedious definitions to this topic here? And the answer is yes. Yes, we can. And as Rich said earlier, we use critical root zone, tree protection zone in sort of very specific ways that I was trained to use, that I use in my reports, that we use in the best management practices. You all may use different definitions. I'm okay with that. You may use these same terms with different definitions as long as you're defining them and using them in your way. That is totally okay with me. This is what I use and what I think it would be great if we all used, but that's up to you all what you want to do. The critical root zone is the area of soil around a tree where the minimum amount of roots considered critical to the health of the tree or structural stability are located. This is the idea, the term, that's going to help us answer, is this tree going to survive construction? For anyone taking a photo of this, feel free to do whatever you want. I'll send you the PowerPoint if you want. I have a handout up here with these definitions on them. The handout is in the app. The handout is on my website. You can get it wherever you want. Everyone's going to buy a copy of the BMPs and have these in 2 months anyways. So the critical root zone is a biological constraint. There is no formula in our usage of this. There is no distance. It is, every tree is unique, and it's literally the amount of roots that you could remove and that tree would still survive. And that if you go within that root zone, the tree's likely to die. If you keep outside of that, it's likely going to survive, because this is a biological constraint to a biological organism trying to figure out whether or not it'll survive. So we'll bring this definition over here to think about our plans. And the next thing that I do on my projects is I measure the distance of our trees to our biggest construction impact, and maybe several impacts depending on the job. Tree number 2, we're going to say, is 10 feet away from the edge of grading, and tree number 3 is 15 feet away. Okay? I need more information still, so I'm going to bring in, we skipped over the whole planning phase. So in the planning phase, we went out there and we collected data. So this happens to be a red maple, 18 inches in diameter. in good condition with high suitability for preservation. It has a dense crown and good structure. Okay? For me, I now have all the information I need to decide whether I think this tree is likely going to survive construction. And that's because I was trained in the Hort science system, where day one, I would partner with someone like Nelda Matheny, and we would look at plans together. We would go out to the construction site, we would assess how much roots were lost, we would look at the health of the tree at the end of the project and hopefully well into the future. Then I would partner with John Leffingwell, and we'd do it again. Then Jane would take me out into the field. Then somebody else would go and we'd monitor construction. And over the course of about a year, I learned how they made decisions and would make my own decisions. And this would happen slowly over time with no formulas, no relationships in any sort of tangible way that I can explain to you right now. It took a long time to develop the ability to do this and sort of understanding how the people before me had done it and this sort of training. We don't have a year right now. We have like 12 minutes. So I want to give you all a tool, an option to try to start thinking about this that doesn't involve this sort of training. For those of you who have a lot of experience with this, for those of you who have mentors who can teach you how to do this, do that. For anyone who doesn't have that, the new best management practices say that you should be able to do this, and I want to give you some ability to do that. Okay? So we're going to jump forward a little bit to another definition, the tree protection zone. The area within which certain activities are prohibited or restricted to prevent or minimize potential injury to designated trees, especially during construction or development. The TPZ should encompass the critical root zone based on the judgment of the arborist. And I just love reading definitions during presentations. Isn't that just so soothing? So one of our main points here is the tree protection zone should be as big as possible. If it can protect all of the roots, great. But it should definitely be bigger than the critical root zone. As it gets closer and closer to the critical root zone, which we don't really know where that is, we get less and less confident that the tree is going to survive construction, right? And so Rich talked about a lot of great science, and I in particular like this Benson paper, and especially this graphic that they created. And how I like thinking about this is, if I can get my entire roots, I like the color coding, because there isn't a formula, there isn't a bright line, there isn't something that says this is good, this is bad, this is going to work, this is not going to work. It just gets worse and worse and worse. So if I'm in the blue zone, I'm not even thinking about that, right? That was tree number 1. If I'm in the green or yellow zone, I'm probably pretty happy. If I'm in the orange zone, I'm thinking, hey, I don't know that this tree is going to survive next summer when it has that drought stress. I'm not sure it's going to get enough water. If I'm in the red zone, I'm thinking it's going to fall over this winter. There's going to be a big windstorm, and we're going to have some serious problems here. And so just my level of comfortability is this color coding system here, if that makes sense. Okay, so if we bring in our tree, we said that it was a red maple, 18 inches in diameter, and it was 10 feet away from construction, right? So 120 inches divided by 18 inches is 6.7x. If we, just to clarify, if this is a 10-inch tree, the math with 18 is a little more complicated, then this is 30 inches, 60 inches, 90 inches, right? That's how we're thinking about this. So 6.7x orange, I'm not very comfortable. That's where I'm at with this, right? But we think that while I said I like this paper, I do have a couple of issues with using this exactly, right? So the abstract in one sentence of this paper is tree protection zones need to be 15 times the trunk diameter as a minimum to avoid the negative effects of water stress. Now, one of the problems with using science in our practice is that we have to adjust it a little bit based on bring in our knowledge. And so one thing is, I'm not trying to answer how do I avoid negative effects of water stress? I'm trying to answer, will this tree survive? So that means we need to change a couple things in how we're thinking about this, right? I'm not going to just use 15x for every tree. Great if I can get it, but if I can't get it, will this tree survive, right? What did Rich talk about as to why we don't treat all trees the same? What's one thing we might want to consider when we're working on this? Species. Who said species? We haven't printed the best management practices yet, but I have printed wildlife best management practices. Copy is yours if you want it, up here at the break. Well done. Species. Based on how I was trained and how my experience in the field, species is important and age variation is important. Older trees, trees of certain species, respond better and worse to root loss and construction impacts. Old trees not so good, young trees a little bit better. Where the roots are. Yeah, so it all sort of depends and brings it in together. There's lots of different ways to approach this. So, I believe we're supposed to wait for questions, but I'm happy to, anyways, we'll see if we cover it. This is a big topic. We could talk about this all day. So, we have another definition. Calculated tree protection zone. This is a table from the third edition. Not a new table. This has been around for 30 years or something. I'm sure many of you have used this in certain ways. Many of you have criticism, probably fair criticism, of that this does not work in all situations. But the calculated tree protection zone is a new definition we're using of a TPZ that is calculated using the trunk diameter and a multiplication factor based on the species tolerance to construction and the age of the tree. So we finally have a formula. We have something to get somewhere in order to sort of base our recommendations on, use our experience with, right? And so we're going to go back to our tree, but we're going to use this table. So who works in this area? I picked red maple because it's native around here, so we're working on a semi-natural area in our project. Who works around red maple and can tell us whether it has high, medium, or low tolerance to construction damage? Yell it out. Medium, high. Okay, it depends, thank you. Yeah, so huge regional variation, huge other types of variation. Most of the literature, most of what I hear from people is that it has high tolerance to construction impact, right? So we're gonna be up here. Now, we all are from all sorts of different areas. This is obviously a photo of a red maple from Portland where it is not native, it is growing as a street tree. So rather than red maple, for those of us in the Pacific Northwest, I'm maybe thinking Fraxinus latifolia. In California, maybe you're thinking Sequoia sempervirens. Across the south, maybe some palm trees. They're a little unique, but. Quercus virginiana in the southeast, maybe Nyssa sylvatica. Does everyone have an example of a species in their region that, on average, does pretty well to root pruning, to tolerance to construction, something like that? Yes. Strong answer. Okay, so if we think this is high, an 18-inch red maple is maybe somewhere between semi-mature and mature. I'm going to say mature for now. And that gives us a multiplication factor of 8. So that means that we think 8x is probably a pretty good tree protection zone for this tree. So 8x is down here in the orange, but we think this original chart told us 15x was what every tree needed. But if we think our tree maybe only needs 8x, we can slide all this over and change our color coding system so that instead of orange, we're more in like a light green, yellow-green sort of range. And so on my report, in my thinking, I think this tree is likely going to survive construction. Does that make sense? Okay. Let's do another example. Tree number 3, American beech, 25 inches. Fair condition, low suitability for preservation, thinning crown, codominant trunks with included bark. So 25 inches, 15 feet away from construction, 180 divided by 25 is 7.2. Puts us back in that orange range, that sort of uncomfortable range, right? Okay, what do people think about American beech for high, medium, or low construction tolerance? Shout it out. I didn't get a single medium? Come on, people. Yeah, the literature says low. My experience with Fagus levitica says low. Different species, but I think we're in agreement on this, right? Okay? Oh no. But we're from all over the country. I don't have this. This is actually a photo of a Fagus levitica because I couldn't even find one in Portland. But in Portland, I'm thinking Populus trichocarpa maybe. California, Juglans heinzii. I've had a lot of problems with post oak in Texas. Maybe we're thinking about eastern hemlock. Does everyone have a species that grows in their natural area that has low construction tolerance that they're thinking of right now instead of this tree if they're not familiar with it? All right. See, we're getting these answers a little stronger. I like it. All right. So if it's low and it is old, I don't know a ton about this species, but 25 inches seems to be declining in health. I'm going to call it old for now. That means 18x. That's even bigger than our 15x that we're using in this science paper. And so we're sliding our scale over and saying, hey, it's even redder. It's even like a dark red here. I'm really concerned about this tree. I do not think that this tree is likely going to survive construction. Furthermore, in the heading of this table 2, as it's going to be in the third edition of the best management practices, it says that this table has always been designed for trees in good condition. This tree is not in good condition. This tree is in fair condition. So if you have fair or poor condition trees, you might think about an even bigger tree protection zone. You might be thinking, maybe we shouldn't be preserving this tree at all, which is sort of what my low suitability for preservation indicates during the planning phase, but that's again, a different sort of talk. So I am not telling you all what to do, except that hopefully you're out there gauging whether trees are likely to survive construction in some way. There's a variety of ways to do it. But in my report, I'm going to write that this tree is not going to survive construction and is planned for removal on this project. You do whatever you want, but I think you have two main options with where we've sort of walked through this from here. If you don't want to write that this tree is going to be removed, what are those two options? Shout it out. Huh? I do not recommend just saying preserve this tree and doing nothing else. If we want to preserve this tree, what would we do? Mulch it. I think we need more than that. Root prune it. I think that's an interesting answer. We'll come back to that. We'll keep going. Who else has one? Irrigation. I assume we're already doing that. Who else has one? Growth regulator is the wrong answer. Yeah, we don't have time for that. I believe I heard somebody say we could redesign, right? We go to the design team, we say, hey, can we give this tree 20 feet, 25 feet, whatever we think it needs, we could go and do that, right? The other thing, I think as Philip said earlier, is we don't know where these roots actually are. We could go out there and do an exploratory root trench and say, hey, are there as many roots as I expect here? Are there more roots? Are there less roots? And adjust from there what we think is going to happen to this tree, right? We could continue studying it. And so once we've made up our mind about tree number 3, we go back to tree number 2, we pull our data back up, say we think that that tree is likely going to survive. Okay, organizers, I can end here. If I have 4 minutes to make one more point, I'd love to, but what's our schedule like? Who's in charge? 2 minutes. I don't know that I can do it in 2 minutes, but we'll go for it. You cut me off whenever you're ready. So I said there's lots of questions we could answer, and I think the next question that I'm most interested in answering is, how will we protect the tree and complete construction? This is, again, in the design phase. So what I see a lot of arborists do is say, hey, for tree number 2, it has high tolerance to construction. We think it's mature, multiplication factor of 8, right? It's an 18-inch diameter tree, multiplication factor of 8. We need 12 feet. Fence it at 12 feet. End of report. What's the problem with this? You cannot fence this tree and adequately protect this tree and complete construction. They're going to take down the fence and do the grading there, or they're going to say, hey, we have a problem here, how do we fix this? And they come back to you. So we solve this with another definition, obviously. We have a new definition of a specified tree protection zone, is a TPZ that's adjusted in size or shape to accommodate the existing infrastructure, planned construction, and specific aspects of the site, while also taking into consideration tree canopy conformation, visible root orientation, size, condition, maturity, species response to construction. We can adjust this after we've done our exploratory root trench. We can adjust this based on the construction that's planned. So instead of that circle, I hope that we all will be drawing something else and saying, we are going to put a fence up at this pink edge here. They can complete construction. It's actually going to protect tree number 1 back there as well. No additional fencing needed, depending on your situation. And then we're going to write some specifications. Ideally, this says something like, you can't do anything on my side of the fence. You can do whatever you want on the other side of the fence. This is not very realistic on most of my jobs. Most of my jobs involve a whole bunch of things inside the tree protection zone, and I have to go there and monitor and do all these things, and it gets way more complicated than this. But this gives you an idea of a tool that you can hopefully try to use in order to try to navigate some of this. Okay, so we're going to do, I believe we're going to have a 15-minute break and then Q&A, is that right? 10-minute break, then Q&A. I've got some handouts up here. Whoever said species, come grab your wildlife BMPs if you want it. Thanks, everyone.
All right, so there was no rest for Ryan or Rich during the break as people had lots of questions, but we're going to take the next 10 minutes for questions. And I think there is a microphone that is circulating around. But if not, raise your hand and then I'll call on or I'll let our questioners call on the...
Daria, do you have a mic?
If you need, I can be the mic person also.
Can we get a mic for them back there? Audio get?
There's
Good
one.
call, Ryan.
Daria looks like she's ready with a question. Sorry to jump in. You know, I have trouble, like, we're going here, right?
Tag team action here.
You know.
Okay, so while the microphone is getting turned on, we'll take 10 minutes of questions, all right? Have at it, gentlemen.
Thank you.
What you got, Daria?
I have 2 questions.
Uh-oh.
The first one, is about sidewalk repair and root pruning around sidewalk repair and where the science is with that.
Oh, the X factor kind of goes out the door. I mean, can you really stay away 15x from it? No. And actually, this is really getting to examination of the root system. So you can lift slabs of concrete really easily without damaging roots. It's then once you have that removed, making a determination of how much you can actually remove. In the BMPs, there's some really good guidance on a lot of different technologies. One, for example, before you even put the slab back in, it's like looking at, not that we'd want to do shaving, but maybe shaving is something you have to do. Or maybe it's like you don't have to shave, and actually we can come up with a more creative way with maybe putting a foam on top of the root system. But then when you put the concrete for expansion, using one of those slip type joints where there's a composite material that joins the slab so this thing can move in a union. So just thinking in terms of that. There's a lot of different options with the VMP.
I'd add one more thing on that, Daria, which is that's for replacing existing sidewalk. Installing new sidewalk in areas that are relatively undeveloped, you sort of go back to more of the using the X system or whatever to evaluate impact.
However, it's not a full depth of 18 to 24 inches, right? It's only whatever.
It depends on the
6 to 8
installation.
inches.
So learning about construction techniques in your area and how they're going to install it and understanding the amount of excavation required is important because in a lot of areas, the planners think of it as this little impact, and then you get out there and you watch them excavate, and it is not a little impact.
Yeah, another thing is also raising the grade, and so you have to obviously think about ADA compliance, 5% slope or below that, is then think about rise over run. How far away do you actually have to start making this gradual increase? And City of Milwaukee's been doing that for, again, now a couple decades, and they've gotten really good at finding ways to actually make the grade, and then make the determination that, no, this is a tree that retention doesn't make sense, and then just eliminating that from the future issues later on.
My second question is about the distance from the trunk is on one side. Is the research only on one side, or is it on all sides?
It depends on the study. And so, for example, it showed you a few up here where it's one or two side. Had a question during break. It's like, how many sides can you cause damage before you get in problems?
Yeah,
That's where I think the calculated tree protection zone is pretty neat. And again, in street tree settings, it's a challenge. It's really it's minimizing damage to the root system by seeing where they're at. It's a little easier once you pull slabs of concrete out, but it gets to that.
Yeah, so the Benson paper, the one that I referenced quite a bit, was 360-degree trenching around the trees.
Yeah, that's a good one. And then on the, you can get away with damaging one side, often. Two sides, you're dicey. Three sides, probably not. Four sides, good luck. 5 or 6-sided damage, which you can do, yeah, don't do it.
Thanks, Harry. Hey, Jim.
Hey, Ryan, Rich, thank you. Maybe I missed it, but there wasn't a whole lot of mention about the importance of soils when considering tree protection or tree retention. And in my experience, there's been a tremendous difference in whether or not I've been able to retain trees depending on the type of soils that the trees are growing in.
What types of soil are better for preserving trees and which are worse?
Sandy, gravelly, well-drained soils tend to have very deep root systems. We've been able to, I've been on sites where I thought there was no chance of retaining trees and found that the soils there were very well-drained, and we've been able to build fairly deeply, right, very close to some of the trunks.
Yeah,
amazing.
So that's so well said that your local area, specific knowledge about that is hopefully what you're going to use to try to answer these questions. The question is the tree going to survive construction? And the BMPs and the science are not going to tell you the answer to that. You're going to have to use your experience and expertise to try to do that. Anything that you think is important to your area. So, Jim, I mostly worked in Bay Area compacted clay soils where there were no roots below 18 inches, right? And so that's often how I would think about predicting where those roots were going to be, what root loss might look like, and how the stability and ability of trees to take up water were going to be from there. But I now work in Portland, where we have different soils and different things going on with the trees. Everything is different. So we have to be thinking about as many of those things as possible. The real question is, what is the root loss going to be? What is the canopy loss going to be? Is the tree going to be able to tolerate that? Trying to bring in as much of our experience as possible. Anything to add to that?
Yeah, I do. Ryan, thanks, first of all, for bringing red maple into the picture.
Yeah,
because in this
love it.
room, you heard low, medium, and Ryan picked high. Red maple root systems in Florida, I heard one person going, it has a low tolerance for construction. Red maple in Florida is a bottomland species. Where I'm at in Wisconsin, it's a bottomland and an upland species. So that root system itself, I could take you to sites around Stevens Point where that root system is really near the surface. Why? Because we have seasonally poorly drained soils, so the water depth of water is not far down. And I could take you to upland sites where you've got a bleak root system. So I think on this whole chart where you had the 3 things Ryan talked about, you have to throw that site factor in there also as your determination. So good setup with red maple. Good question to actually bring this into the arsenal.
Hey, Jeff.
Yeah, are there any design engineers in the room?
Uh-oh.
All right, so what is the best strategy then to engage the design engineers and the people at that level that we have to have engaged in order to accomplish our objectives?
Well, I mean, you can be punitive. And who likes to be punitive? I think educate before you regulate. If you remember Jesse the Body Ventura, that was his mantra to get elected in Minnesota, was like, educate before you regulate. So that's an important thing, but sometimes you have to do that. But I think you said something, Jeff. What about the designers and the engineers as part of their BMPs as just like their code of ethics, cause no harm, like a doctor? I don't know, maybe that's a solution, is like getting at the table there, and that's just part of their engineering. It's like causing no harm. Because if you're a contractor engineer and you damage the crap out of buildings and sidewalks, do you think they'd do that? No, they just don't do that, okay? I think there are better mindset, but on the tree component, somehow that getting in there. And I told you my pain in Wisconsin where there's state projects, but the state planners are down in Madison. They never come up to our site as much as I know. But trees are not part of that discussion, and we've tried to get it in there. They just have not been receptive to it yet. Don't know. I've even got friends that work down there, and they've tried to. Sometimes it's political appointees come in, and so the lifespan of people in some of those buildings is small. You got a good solution, Philip?
I've always worked in highly regulated areas, and so largely they're forced to do this. And sort of the relationship between my clients, the city, me, and the designers becomes sort of collaborative, where we play this important role in trying to help them navigate these city ordinances. There's lots of other models and lots of other ways to work collaboratively with designers, and that's sort of always been our approach, is that if you can be part of the design team very early on, even in the early planning stages, that allows you more ability sometimes to be able to influence the design, be able to talk to them early on about which trees should we focus preservation on, all those sorts of things.
We do have a window, though. In Wisconsin, for example, another place, sustainability is just a really important construct. So actually on the sustainability side, that's actually an inroad with trying to make this happen. Because retention of existing things makes more sense than delaying recovery of canopy 40 years down the road.
Absolutely.
You've partially answered some of my question, but I agree that in the planning and design phase is the best chance for us to get involved and make changes. Does the new BMP cover construction administration, the follow-up in any more degree than the previous?
I'm going to say largely I think not. And I'll just make one point of that often the comments we get on the best management practices, we sort of put into a category of that people want it to be more of a how-to document. And that, I don't understand a ton about writing best management practices. It's only the second one that I've really worked on. But trying to find the line of giving people tools and practices without telling them how to do it is a line we try to draw, and I think you may be sort of skirting that line, if you know what I mean there.
One more question.
All right.
More of a comment. I'm glad to see that you've incorporated in the new revision a little more latitude for us to be more creative and do more things, because the city people tend to just follow those as if those are specifications. And on a project, we end up just checking the box to make sure that we can get the permitting. We owe it to our clients to help them get their permitting, but sometimes we're shut down by the requirements just checking the box so that we make sure. So I think it's important that the regulators are educated and that they can understand that each site and each tree is different and give us a little latitude to be more creative.
Well said. I think that brings up an interesting point of the audience for these best management practices. And I largely think about the audience as consultants, right? As with a very broad definition of consultant, of if anybody is showing up on a construction site, giving advice about how much space a tree needs, anything, you are operating as a consultant and giving advice that our best management practices are largely written for you. They are not written specifically for the sort of municipal sector of how do you regulate trees and how do you enforce some of these things on their side. I think there's a lot of things in here that can be applied to that should be applied to that, but it's not sort of directly written for that, and trying to just take pieces of that and fit it into your policy is not going to work super well unless you've sort of thought about it and how to do that.
It's a good way to end. And if you've got more questions after this session, just reach out to us during break or throughout the day.
Yeah, and I know you all have lots of experience with this. I look forward to hearing more about that and what you all are doing out there. So thanks, everyone.
Thanks.